There are two very specific proof by inductions on the course. One of them is deMoivre's theorem, so we're going to prove this now. So we just need to prove it for natural numbers n, so positive whole numbers from 1 up. So the theorem says that cos of theta plus I sine of theta to the power of n, you can just bring the n in and get cos of n theta plus I sine n theta. So that's what the theorem says. So seeing as it's the proof by induction, there are 3 steps as ever. So step 1 is we check for initial values. So check true for the initial value, and the initial value here is n equals 1. You could do it for n equals 0 as well, it'll work for that too. So cos of theta plus I sine of theta to the power of 1 is equal to cos of 1 theta plus I sine of 1 theta, and that's true. The left hand side is just cos of theta plus I sine of theta, the right hand side is cos of theta plus I sine of theta. If you'd done it for 0, you would have got something to the power of 0 on the left, which would have been 1. You would have got cos of 0, which is 1, plus I sine of 0, which is 0, so you would have had 1 equals 1. So it'll work for 1 as well, for 0 as well as an initial condition. So step 2 then is assume true for n equals k, where k is bigger than or equal to 1. So we're assuming that cos of theta plus I sine of theta to the power of k is cos of k theta plus I sine of k theta. So this is star. This is what we're going to use to do the real work of the theorem. So that's star there. Alright. So the next thing is step 3. So show true for n equals k plus 1. In other words, we want to show that cos of theta plus I sine of theta to the power of k plus 1 is cos of k plus 1 times theta plus I sine of k plus 1 times theta. And this is our aim. This is what we're aiming to show. So we generally put a big bracket on that, because we're not supposing it's true, we're aiming to show that that is true. So what we do is we take star, and as usual when we have an equals, we try and manufacture either the left hand side or the right hand side. Now looking at that, it's going to be much easier to get to relate the left hand sides than it is to relate the right hand sides. All we have to do to get from this left hand side to this left hand side is just multiply by cos theta plus I sine theta. Alright, so let's do that. So let's go on to the next page. So multiply both sides of star by cos theta plus I sine theta. So we get cos of theta plus I sine of theta to the power of k plus 1. That's what we get when we multiply. If we take this left hand side and we multiply it by cos of theta plus I sine theta, we get that joke to the power of k by that joke. So that's that joke to the power of k plus 1. Alright, we're using the fact that a to the power of k by a is a to the power of k plus 1. And what we're doing there is we're adding the powers, and remember that power there is a power of 1. Alright, so that's cos theta plus I sine theta, cos theta, so that's what we're using. Alright, so let's multiply the right hand side by cos of theta. So we get cos of theta plus I sine of theta by the right hand side of star, which was cos of k theta plus I sine of k theta. Alright, so that's the left hand side that we're aiming for. We need to show that this is the right hand side we're aiming for. So what we're going to do here is we're going to multiply out the brackets. There's not a whole lot else we can do, so we multiply out the brackets. And we're going to collect the real parts together and the imaginary parts together. Alright, so that's meant to be an arrow. Didn't really turn out very arrowful. So we get cos of theta, cos of k theta, plus cos of theta times I sine k theta, plus I sine of theta cos k theta, plus I squared sine of theta sine of k theta. Alright, so looking at this now, we have a real bit and an imaginary bit. So the imaginary bit is this and this. And the real bit, if you remember that I squared is minus 1, then the real bit is this and this. Alright, so let's just rewrite that. So that's cos theta cos of k theta minus sine theta sine k theta. So we've just put the two real bits together. And then the two imaginary bits, we have plus I times cos of theta sine of k theta plus sine of theta cos of k theta. Now it helps at this point to know what we're looking for, and we're looking to show that this thing is cos of k plus 1 theta here, plus I times, we want this thing to be sine of k plus 1 theta. So that's why we go to the log tables and we have a look and see, well, what's the story with cos of a plus b and sine of a plus b. And if you look up the log tables, you'll see that cos of a plus b is cos of a cos of b minus sine of a sine of b, and that sine of a plus b is cos a sine b plus sine a cos b. So using these two, if we look at the first one, we know that this should turn out to be cos of a plus b. So if we think of that as a and that is b, then that's a and that's b, and we can see that what we have here is cos a cos b minus sine a sine b, and that's just cos of a plus b. So that first part, the real part, is just cos of theta plus k theta. The second part, again, we think of this as a and this as b, this as a and this as b. Then you have cos a sine b plus sine a cos b, and that's the right hand side of sine a plus b. So this whole thing here just turns out to be I times sine of theta plus k theta. And that's pretty much it. We just need to write it as factor out the theta here, and you get k plus 1 times theta plus I sine, factor out the theta, and you get k plus 1 times theta. And that's the whole proof. So the main thing to remember here is to check it and do the steps. Check it in the first case. Step 2 is the assume this is true. Write down what we want to prove is true, and then if we take this and multiply both sides by cos theta plus I sine theta, we'll get the left hand side we're looking for. Then it's just a case of taking the right hand side that we have, which is move that down there. Taking the right hand side we have, which is this here. So that's the right hand side of star multiplied by that extra term. Multiply the whole thing out. Real goes with real, imaginary goes with imaginary, and then look up your log tables. And because you know what the answer is, you should have a good idea what you're looking for. So you know that this should turn out to be cos of a plus b, so you look for the cos of a plus b formula, and it is exactly how it should be. You know that this should turn out to be sine of a plus b, so you look for the sine of a plus b formula, and it works out in about 2 months.